What does it mean for a relationship to be linear? Well, let's take a close look at these tables and see how they show what it means to be a linear relationship. What we're going to do is compare the change in our y values to the change in our x values. So starting with the table on the left, I can see that my x values are increasing by 1 each row, and my y values are increasing by 4 each row. So my change is the same with each row, and every time if I were going to write my change in y over my change in x, I would write 4 over 1. So that's my rate of change for this table. My rate of change is 4 over 1. I could write that m equals 4, since 4 over 1 simplifies to 4. Now let's look at this other table. One thing you're probably going to notice right away is, hey, wait a minute. It increases by 1 here, and 4 here, and 2 here. So my x values, the rows, are changing by different amounts every time. Could this possibly be linear? To find out, we have to dig a little deeper. So let's see, this row in the y's changes by 4, and this one changes by 16, and that's an increase of 16, and then here we have an increase of 8. So now I have 4 different ratios comparing my change in y to my change in x, right? So I have 4 over 1, and I have 16 over 4, and I have 8 over 2. And what I'm wondering is, are those the same or are those different? Well, I know that I can simplify these fractions, and in fact, 4 over 1 is equivalent to 16 over 4, and that's equivalent to 8 over 2. So these all represent the same value. The ratio of my change in y over my change in x is equivalent for any row of my table. I could have chosen any 2 rows and I would have gotten a ratio equivalent to 4 over 1. And that's what it means to have a constant rate of change. So that's going to be our magic word to think about when determining is a relationship linear or not. We're going to look at the rate of change and see, is it constant? Is it always the same? If it's a constant rate of change, then it's linear. So that's an example, but let's think about how that would look in a graph. In a graph, we're going to call that constant rate of change a slope. A slope is just really a measure of steepness, right? So you can see this tractor is on a very steep hill that I wouldn't want to mow. And here's a lawn that looks more like my front lawn, and it is not steep. And this is exactly what slope measures. It measures how steep something is. So when we're talking about slope, that means we're talking about graphs. So here are the graphs of the tables that we were looking at. The first table is graphed here. And remember, we said that our rate of change was 4, so every time x increases by 1, y increases by 4. And here's where you can see that in the graph. So y increases by 4 and x increases by 1. Y increases by 4 and x increases by 1. Y increases by 4 and x increases by 1. So my rate of change is constant in my graph. I can see it that way too. It's 4 over 1. And here's what I typed into Desmos in order to create this graph from this table. Another thing to keep in mind, because the students are going to ask, is, well, what if I picked a different point? What if I went from 0, 0 to 2, 8? Then I go up 8 and over 2, and isn't that a different slope? No, it's not, because 8 over 2 is equal to 4 over 1. So I still have a constant rate of change. Whichever 2 points I pick, my rate of change is the same. My slope is the same. And in fact, we have a standard 8.4a that addresses exactly that idea. It talks about similar triangles and similar right triangles and how they can be used to show that the slope is the same whichever 2 points I pick. Now let's look at this other table that we were talking about earlier. Remember, we also said that this one had a rate of change of 4 over 1. We just had to use equivalent fractions to see that, or equivalent ratios rather, to see that. So looking at this graph, I am going to pick, I think, 0, 2 to 5, 22. So let's see. From 2 to 22, I went up 20. From 0 to 5, I went over 5. So that would be 20 over 5, and that's equal to 4 over 1. And you know what? Let me just add some little marks on this graph. I can see I could go 4 up and 1 over, 4 up and 1 over, 4 up and 1 over, 4 up and 1 over. And I could do that all along my line. And if I go 4 up and 1 over, I am always going to land on a point that is on that line. And that is because that line has a constant rate of change. So that's what it means for a relationship to be linear. So in summary, when we look at our table, we see that our table has a constant rate of change, and it doesn't matter which rows I pick. When I look at my graph, I see that my graph has a constant rate of change, and when that rate of change is on a graph, it's called our slope because it measures the steepness of the line, and that slope is the same no matter which 2 points I pick. And because that is constant, my relationship is linear.